a very interesting manifestation of field extensions comes from numbers that can be constructed using a straight edge and compass. You've seen these constructions in school. A straight edge is basically a ruler without any markings, and a compass is a device to draw circles given a center and a radius. Now, a straight edge and compass construction is a series of steps. So the first step is always that you're given 2 points. And I'll call these points constructed points. So basically at each stage of a construction, you will have a set of objects that are constructed at that stage. And at each new stage, you will construct a new object according to certain rules. The first step, you're given 2 constructed points. So these could just be 2 points, and usually we denote them by O and A. And the understanding is that the distance between these 2 points is 1 unit. Okay, so what can you do at each stage? So at each stage of the construction, you can do one of several things. So firstly, what you can do is you can join 2 constructed points by a line. Okay, when you join 2 constructed points by a line, then that line is among your list of constructed objects. So that line has now been constructed. Then what else can you do? You can draw a circle whose center is a constructed point, and radius is the distance between 2 constructed points. Okay, so you can only draw circles with such centers and radii. And what else can you do? You can construct new points. So you can construct a point at the intersection well, there could be more than one intersection. So at an intersection of a constructed circle with or line with another constructed circle or line. Constructed circle or line with another constructed circle or line. Okay, so the objects that you're constructing at this stage, so if you join 2 constructed points by a line, this line is constructed. And if you draw a circle whose center is a constructed point and radius is the distance between 2 such points, then the circle has been constructed. And you can construct a new point by taking the intersection of either 2 lines or 2 circles. Well, if you take 2 circles, you could have 2 intersection points. You can choose either of them, and you could also take the intersection of 2 points. And now the definition of a constructible number is the following. So this whole definition is the definition of a construction. It's a series of such steps. Okay, so the definition is a real number x is said to be constructible if it is the distance between two constructible points. Okay, and you can ask which real numbers are constructible, and that's the question we're going to answer. Now note that a construction is a finite sequence of steps, and at each step you only have a finite set of possibilities. So the number of constructions is countable, and so also the number of points that you would have in any construction is finite. So the number of possible distances that real numbers that you can construct is countable. And so there are very few countable real numbers. Most real numbers are not constructible. And let me illustrate that the square root of 2 is a constructible real number. It's probably one of the simplest non-trivial examples. So I'm going to use a package called GeoGebra to do this. It very nicely implements constructions. So we start with 2 points, O and A, and the distance between these 2 points is deemed to be 1 unit. Okay, and then we can draw a line through it, and we can draw a circle with center O and radius given by the distance from O to A. And we call that circle C. Okay, so you can read the code here. It's a circle C with center O and radius the segment O to A. And now we can try to find the intersection of this circle C with the line L. Okay, there are 2 points in the intersection, this point B and the other point is A. So GeoGebra gives me both the points. I will not display this other point, B2, which is also the same as A. And now what we'll do is we'll construct a perpendicular to this line L using these points B and A. So now what I'll do is I'll take a circle with center B and radius B comma A. Okay, that's the orange circle. I'm calling it S. And similarly, I'll take a circle with center A and radius the distance from A to B. I'm calling that circle T. Now these circles S and T, they intersect in 2 points, P1 and P2. And so I can now, these points have also been constructed, and now I construct the line V as the unique line that passes through P1 and P2. And now let's look at the intersection of V with the circle C which we had drawn earlier, and I'm calling that point Q1. There's another point of intersection which is called Q2. Okay, but I won't really be needing that. And now I have this point Q1. Now because OA and OQ1 are both radii of a circle, OA and OQ1 have the same length. So OQ1 is also 1 unit, and by our construction, this angle OAQ1 and BOQ1 are equal, and so they are right angles. And so this OQ1 A is a right angle triangle with right angle at the vertex O. And so if you take the segment Q1A, that segment has length square root 2. So this is a construction of square root 2. The rules are a little stricter than what we did in high school geometry, where we were usually allowed to choose any radius that we liked. And we're also allowed to choose arbitrary points. But here we're only allowed to take points which are already constructed and not introduce any new points. Okay, so the question is, which numbers, how can we tell if a number is constructible or not?